Profile control is a highly versatile and a highly holistic type of control in which we can control the size, the form, the orientation and the position or location of a surface feature, of any surface feature, whether it be cylindrical surface feature or whether it be non-cylindrical or flat surface feature. It can be used to control any surface feature with respect to a datum scheme or without a datum scheme. So here is a profile control which has been applied without a datum. So this top surface of this component is being applied. The top surface is having a radius of 28. So that is a curved surface on top. This indicates a curved surface, and that has been applied with the profile control of a profile of a surface, and the tolerance range is 1. The tolerance zone width is 1. That means that two offset surfaces, one above the nominal surface and one below the nominal surface, form the tolerance zone. So any point on this surface should lie within that tolerance zone. Here there is no datum applied along with the geometrical tolerance value, which is 1. That means that this control, this profile control without a datum applied, only controls the form of the surface. So it only controls the form of the surface, which means that, so here is the tolerance zone. This is showing the tolerance zone in 3D. So this is the top surface and this is the tolerance zone, the curved tolerance zone, which is formed by two offset surfaces. So what this means is that it only controls the form variations. So this geometrical profile control only controls the variations in form of the top surface, which are shown over here. So any wavy variations in the form are being controlled with respect to this profile of a surface feature control frame. This tolerance zone, like flatness and straightness, is not defined with respect to any datum. Hence, the location and orientation of this tolerance zone is not fixed. It can vary with respect to the position of the actual component surface. So if you want to control the orientation, let's say if you want to control the orientation of the top surface with respect to this baseline, which is this base surface, we don't want it to go inclined like this. This control does not control for that, does not account for that. It only accounts for the form variations as shown. It should not be wavy within a tolerance zone of 1, but it can be inclined like this, or it can be positioned over here also. So this surface can also be positioned over here, and it would not violate this profile control. Now in the same drawing, if you are adding the datum feature, so if you are adding a primary datum feature A as shown over here as the side face of this part, and if you are changing the profile control to this, that is the profile of the surface has to be controlled within a tolerance zone of 1 with respect to datum A. What this means is that the profile of the surface has to be controlled with respect to its orientation with respect to a reference, which is the datum A, which is nothing but the plane of this surface. So the plane formed by this surface, with respect to that, the orientation of this surface, that is the red color line, that orientation has to be controlled within a tolerance zone of 1 mm. What this means is that if you are making a tolerance zone equally spaced with respect to the nominal surface as shown over here, these two lines in blue indicate the tolerance zone of 1 mm. This feature, that is the surface, can rock in between the tolerance zone which is defined by these two limits. So what this means is that the actual surface, which is denoted as the red color curve, can rotate like this, but it can only rotate to the extent that it is within the tolerance zone as defined by the two blue curves. So the rotation of this red color curve or red color surface has to be within the tolerance zone, which is defined by the boundaries as shown over here in blue. So this is an image in 2D, but actually it happens in 3D. So the 3D rotation of the red color actual surface has to be within the two blue color lines or blue color boundaries. What that basically means is that the orientation of this surface with respect to this line, which is indicated over here as the primary datum feature A, the surface of the primary datum feature A, that angle is varying. So if you plot an angle with respect to, let's say if you draw a chord over here connecting this point to this point, if we draw a chord by geometry and then we measure an angle, let's say in this case it is 90 degrees as the nominal. So that 90 degrees can vary to a certain higher value and to a certain lower value, which is defined by the extremes of the curve as located within the tolerance zone, which is defined by these two boundaries which are spaced with respect to each other of 1 mm at equally spaced with respect to the nominal surface. So basically we are defining the orientation of the actual surface with respect to datum feature A, which is this line. That orientation change is resulting in spinning or rocking of that feature. And that rocking of the path surface is being controlled with respect to when we use this profile control with a single datum, and when that datum is defined as the side wall of this component. Now instead of this side wall, if we had defined the primary datum feature as this bottom surface, then the rotation of the profile which is allowed would be in a different way. So the mode of variation of orientation will be different as compared to this case if the datum feature was applied on the bottom surface. So depending on the datum feature where it is applied, the orientation or the changes in orientation of the surface will differ, and that has to be within the tolerance zone as defined, which is spaced at 1 mm with respect to the nominal surface. In the next level, let us add another datum. Basically that would control the location or position of that surface as shown over here. So we had a primary datum feature A. Now let us add another secondary datum feature B, which is on the bottom surface of the path. So this is the bottom surface of the path, and in the feature control frame of the profile, we are adding another datum B. So profile control, that is the surface has to be controlled with respect to its profile within a tolerance zone of 1 with respect to datum A, which is the side face, and datum feature B, which is the bottom face. And there is an additional basic dimension which has been given over here, which is originating from the datum feature B and which is locating the center of curve, the curve which is having a radius of 28. So that basic dimension is locating the surface feature with respect to datum feature B. So this feature control frame also adds a control in location. So earlier in the orientation control over here, there is no control on location of this surface. So this tolerance zone is not located rigidly with respect to any datum. It can move. It can move up or down. The tolerance zone itself can move up or down, and so can the actual surface. Only thing being controlled is that the rocking or the rotation of that surface with respect to datum A is being controlled, but the actual position with respect to any other feature is not being controlled. But here, when we are having the additional datum applied and the basic dimension is applied, the meaning will change. The meaning is that the position of this surface also has to be controlled with respect to the basic dimension 50 with respect to the datum feature B. So this position control also implicitly controls the orientation. That means it controls both the rocking with respect to datum A and also the position with respect to datum B. So we have already seen what rocking means. Position means this variation as shown over here. This variation of this blue color line as it goes up and down is varying in its location with respect to datum B. So this feature control frame controls the actual surface such that it can rock within the tolerance zone of 1 space with respect to the nominal surface, and the actual surface can move up or down within a tolerance zone of 1, which is defined as shown over here. So definition of the tolerance zone with respect to its location, to the location of the surface, and the definition of the tolerance zone with respect to its orientation or rocking will be separate, and both are being controlled in this feature control frame for the profile of the surface. If you are adding additional datum as shown over here. If you are having a datum like this, so datum feature C is being added to this face, this face is datum feature C, this face is datum feature A, and the bottom face is datum feature B. So bottom face is datum feature B, this face is datum feature A, and this face is datum feature C. And then we are changing the profile control. So profile of the surface has to be within a tolerance zone of 1 with respect to datum A, B, and C. Now, what this does is, this basically controls the orientation. As we have seen, the rocking within the tolerance zone is controlled with respect to datum A. Also, it controls the rocking of the whole surface with respect to datum C. So if we consider the side view, which is this view, and this is datum C, the surface can be oriented like this. So the orientation of the surface can go like this, but that orientation of the surface should be within the tolerance zone. So the orientation or the rocking of the surface is shown over here, how it can change. So this surface has changed in orientation with respect to datum feature C, and that change in orientation has to be within the tolerance zone. So it gives an additional layer of orientation control. So the first layer of orientation control is orientation with respect to datum feature A, which is the rocking, which we had seen earlier. One layer of orientation, another layer of orientation control is orientation of the surface with respect to datum feature C, which is shown over here, the inclination of the surface with respect to datum feature C. And then there is the location of the surface with respect to datum feature B. So it controls two types of orientations, and it controls one type of location. And also on top of that, it also controls the size. So the size is also controlled when it comes to profile. Profile implicitly controls the size of the profile also, because larger and smaller size, because in this zone, as you can see over here, this is increasing the radius of the curve. This is reducing the radius of the curve. So indirectly, we are also controlling the size of that curve. Indirectly, we are also controlling the size of that curve. That is the reason why profile controls the size, form, orientation, and position all together. In this case, orientation is being controlled with respect to datum feature A separately, and orientation with respect to datum feature C is controlled separately.